Okay, and now our next speaker is Östring, and Isa is going to tell us, he's from the telecommunications and software industry, as I understand, and he's involved in the, DATEX-based systems in Finland, and he's going to present us something about new development of urban DATEX nodes in Finland. So Isa, please.
Thank you, Joseph. Yes, thank you for the introduction, Joseph. I come from a small Finnish company called Infotripla, and we are providing ITS services for transport and logistics business areas. And we have been doing this all of the company's existence from 2001, and we have been involved in very many interesting things within the ITS services in Finland. And our main customers are, for example, the Finnish Transport Agency, cities and regional agencies, and companies providing services for end users and for transport professionals. And in this presentation, I will mostly concentrate on cities here, which the title, of course, is the urban nodes. And we have been hosting DATEX II services since 2012 in the city of Oulu. And this is sort of the playground that we are working on. Our core is in the center, the data storage or data processing, if you like. And we have data coming from different sources to systems. We don't own the measurement devices ourselves. We have agreements to data providers. We have made data creation tools, which I will describe in this presentation shortly. And those sort of two inputs feed our core data storage database. And with data processing from that core information, we will have as an available different products for different user groups. We have end user solutions, traffic information portals, for example, and public display views and so on. And we have, of course, we have DATEX II standard interfaces for a couple of cities and for the whole of Finland also. And the last round one on the right is for transport professionals. We also store the data that we gather and provide additional services, meaning helping the cities keep up with the loop counters, for example, if they get faulty and so on. We will compute indicators from those data and provide the reports to the city personnel. And a little bit background for these urban nodes. The data will be and has been collected for the agency's needs. And the public sector wants to publish the data as an open data. And we are helping those organizations, cities for example, to publish that data as open data. And we have been hosting the DigiTraffic service since 2008 for the Finnish Traffic Agency. And that has been a good practice and a good background for us to approach the cities later on. And cities themselves have started a little bit later than the national authorities, but their activity is going very strongly on right now. But what I would like to mention is that the data quality varies from city to city, and so it requires some different types of processing, maybe some different approaches and so on. And this is vital to provide the urban information from the city's data, because national authorities provides information only on the main roads, not inside the cities. And our role in this market is to provide solutions for public sector to open the data. And it includes our expertise in traffic, data integration, technology development, hosting the services, maintenance, and of course supporting the data delivery system, so reporting back the problems to keep the data flowing. And our solutions are offered as a service, and that keeps us on our toes in order to get our bills paid. Because if the cities get good quality from our services, then we have the permission to send the invoice. And there are basically two kind of data sources for urban DATEX nodes. The fluency information is based on the data from automatic measurement points, traffic light systems and probe vehicles. We have fleets of taxis in different cities in contract with us, so we will get the taxi data, and the traffic light systems provide also important information, mainly the counters within those traffic lights and so on. And the unplanned and planned traffic events are created by the city personnel. Typically there is one person who is responsible for reporting the unplanned or planned traffic events, and they are using that with our tools. And the tool is a web-based application, and it provides a map interface to easily input the unplanned and planned events. And the city, they decide the informing strategy and guidelines, and they might vary from city to city. And the FTA, Finnish Traffic Agency, decides on a national level of the informing. And some basic things about the data. It's stored in our database. As I mentioned, the person inputs the data with our tools. The data is stored in our database and processed and then published. And DATEX II is not the only interface that we provide. It's dependent on the customer, of course. For example, the web feature service WFS is one that we have been using and are developing, and WMS web map service, which is mainly for visualization, not for getting the actual numbers. And the data interfaces that the cities have, they are published and documented on cities' open data catalogs, amongst other open data which they have. And we understand that traffic information is real-time and more dynamic than the other types of open data that cities might have. And that means that putting the data available is not the only thing that can be done or should be done. And often the users, the end users, would like to ask some questions, and probably the cities are not capable, or they have not enough resources to answer that kinds of questions. And they will rely on us, and we offer that as a service also, that we have the customer service with us. So the end users can, maybe not directly, but depending on the agreement, maybe so, but we provide the support for the interfaces also. And here are listed the DATEX II nodes that we have published. City of Oulu 2 years ago, City of Tampere this year, and there has been discussions with our capital city Helsinki for the next year. And the type of interfaces we have, they are DATEX 2.1 interfaces, and no extensors have been necessary so far. And there is basic access authentication securing the interfaces, but because those are open data, you can get the credentials if you ask them. And there are also other commercial DATEX 2 publications available from us. What are the benefits? To inform the citizens about the traffic, help to maintain and develop the quality and service level of the traffic system, and provide value added to the existing commercial information if they would like to use them. And as a last slide for my presentation, something to be discussed maybe later, maybe now, what we have been inside our company discussing and with our clients also about the data, because the capability and processes vary from city to city, and the quality also varies from city to city. And we value the utilizer's point of view, for example, that must they have all data from all cities in a country, or are they more or less satisfied with that all data is good data? That if the situation is not homogeneous within a country, is it so that the all data is good data anyway? Okay, thank you.
Okay, any questions?
Okay, thank you. My question is that you mentioned you were using taxis as probe vehicles. In many cities, taxis can use bus lanes and are not the standard traffic, do not denote the standard traffic patterns. Was that a problem for you? And if so, how did you overcome it?
Yes, thank you. That was a good question. We have, of course, identified that traffic taxis can take the bus lanes, and so on. They don't reflect the actual situation of the personal vehicles, for example. But the data that we are using is mainly on the streets that there are no lanes for bus traffic. So the information is, that sense, is more reliable, and it doesn't pose a problem in that sense that it's a very limited resource, the bus lane, at least in those cities that I have mentioned. But I think that in the future we have to tackle that somehow, and of course we have to take the traffic light information, of course, into account so that the traffic is stopping when the lights are on red and so on. That poses also a problem to the floating car data. But this is something that we have to develop further. Thank you for the question.
Anyone else? Okay, I have two for you. Try to be brief. Question one. You mentioned, as well as Paul, you mentioned cities benefiting from data being made available for apps. And we've heard already some remark, I think, from you that the app developers community is complaining about DATEX processing quality. This is, I think, what it is. Yeah, so I think these guys don't like to have a validating XML parser in the smartphone. Do you have the same experience? Can you support that?
Yes, we have faced the same kind of a problem because from our perspective it's also very, let's say, causing quite a lot of traffic if individual mobile phones are collecting data from our servers, and this is something that we have been hoping for, the sort of the light delivery mode for the end users, for the mobile applications, for example. And let's say that by agreement, most of our DATEX II interfaces have been restricted on a server-to-server communication. This is how we have been handling. Maybe it's not a nice way regarding the application developer, but it's a sort of a safe way for us to provide the service level for the other users.
Okay, good. So we've heard that twice, and you're shaking your head as well. We heard it from the Netherlands today, so I think time is there to think about a thin layer on top of DATEX with service provision, maybe via JSON or something into mobile applications.
What we actually did to accommodate for lightweight users was to provide for a GML extension, that we actually provide GML to all our sectional data, so they can plot it directly without having to decode and do the location.
Thank you. That would have been my second question. You mentioned web feature service, which means you have GML coded content in there. How did you do that? Because I remember we had it 10, 12 years ago. We had a European project called Emotion that did a mapping of DATEX II content to GML for the purpose of publishing it as a web feature service. So you guys must have made the same exercise, probably. Yeah? Can we collect that experience? I mean, it's not necessarily easy to map DATEX to GML.
What we are basically doing is not directly DATEX to XML conversion, because we have the actual source data, then we have a sort of a shortcut to the GML data. That's a nice for us, but
I think we tackled a good question here. If you had a proper mapping, you probably would have used that. Okay, so what we have to go on.